Hello, I'm Marco Brambilla and I'm a professor in computer science and data science at Politecnico di Milano. In this lecture, we will introduce and motivate the role of data science in creative industries, describing the concept of data-driven decision-making and the role of conceptual modeling in addressing the complexity of reality. After, we will see them at work in a case study. Decision-making within companies is frequently addressed without considering factual data. Sometimes pure intuition or personal experience lead choices. Even the highest paid person opinion, or the so-called flippism, which means deciding randomly between possible alternatives, are adopted. In the digital era, we can dream about data-driven organizations where decisions no longer have to be made in the dark or based only on gut instincts. They can be based on data, evidence, experiments, and more accurate forecasts. When organizations go in this direction, they better perform because the data shows where they can streamline their processes and improve their businesses. Moreover, they become operationally more predictable as the insight they gather from the analysis of the data feeds current and future decision-making. And therefore, they also tend to be more profitable, since constant improvements and better predictions help them to outsmart the competition, improve their market presence, and foster innovation. To demonstrate the concept of data-driven business, we consider the case of Netflix. I think we all agree that Netflix is a great success. Just looking at the numbers, it currently reached 135 million paying accounts worldwide. But Netflix is not only a successful service, it is actually a completely data-driven service. With no ads, Netflix's business model only relies on subscription fees. The happier the customers are, the longer they will stay subscribed to the service. This is why it is central to Netflix's business to identify and analyze factors that impact viewers' enjoyment. Netflix captures users' enjoyment through ratings given to movies, but it also records many other features of the user behavior. The time and the day each content was watched, the user gender and age based on individual logins, the time spent selecting movies, how often a movie or program was paused and resumed, how frequently the trailers are played, and so on. Using these data points, Netflix data scientists and engineers built models to predict the perfect situation, in which customers continuously receive suggestions of programs they will enjoy. To do so, it assigns users from 3 to 5 clusters among more than 1,300 clusters, based on their viewing preferences. It also implements the alt-genre data-driven categorization of movies, corresponding to different strips of movies in the user interface, featuring titles like TV programs featuring a strong female lead. They are scarily specific category suggestions that sum up to around 80,000 unique ways to describe the type of movies. Clearly, they go far beyond the classical categories like drama, comedy, or science fiction. They were also created bottom-up using data science techniques. Netflix builds cover images for movies on the colors and styles of successful, similarly tagged programs seen by the customer to help draw new viewers in. It also experiments with different versions of the cover images to validate which ones are more effective. In conclusion, we can say that Netflix disrupted the TV industry by using data science to provide viewers with the content they want. Similar businesses exist that do the same in many different fields. Think of Uber, Airbnb, Amazon, and many others. Essentially, they are all data companies. Now, let's start understanding how this can be achieved. The first point to be made is that we need to realize how complex reality is. As a famous data scientist, actually Shakespeare, said some time ago, There are more things in heaven and earth than we can imagine and try to describe with our theories. This implies that any interpretation of reality requires the collection of raw data, which must then be understood in order to be transformed into meaningful information. From there, we need to further extract repetitive patterns to build valuable knowledge, which in turn will probably serve us to reach wisdom as a long-term goal of our life. To tackle this path, the human mind continuously reworks reality by applying cognitive processes. It widely applies abstraction, that is the capability of finding commonalities and building a unifying model across multiple experiences. Therefore, we describe reality in a simplified way through the definition of models. Indeed, we can define a model as a simplified representation of reality, specified in order to accomplish a specific task. Models are all around us and are also excellent communication tools. For instance, this picture can immediately be recognized as a subway map, and it's nothing more than a model as it simplifies the complexity of the subway system so as to convey only relevant information to the travelers. Models are the core ingredient of data-driven decision-making, and they are at the intersection among data science, big data, machine learning, and artificial intelligence. For example, if we want to represent the reality of a city and the behavior of people living there, we can represent it with a model like this, in which we represent the city, the places within the city, the people present in the places, and the activities they perform in terms of posted photos, relationships with other people, shared contents, and so on. Somehow, we can still borrow Shakespeare's vision so that we can see a duality between the digital world of data and the reality of the facts we want to discover and analyze in the physical world. Indeed, we have a digital sphere from which we can gather information, for instance web, social media, other sources, to better understand the reality of the physical space below and its complexity. It is important to be aware of this complexity to understand that adequate tools are needed to deal with it. Actually, already in 1979, Joël de Rosnay conceptualized the idea of a tool called macroscope as a multi-lens tool that allows to capture and interpret complex realities from many perspectives. However, back then, this tool remained an abstract idea, because there was no technical means for collecting and analyzing all the data needed for describing completely the complex system of interest. Nowadays, with big data, data science and machine learning, we are able to implement our own macroscopes for almost any scenario.